Hello YouTubers, this project is about interfacing microcontrollers to your Android device. The project actually started a while back with my fascination with the Yo-Yo device available on Spark Fun for $40. It's essentially a microchip microcontroller, and it has firmware on it that interacts with different types of pins: GPIO, PWM, ADC, I2C, SPI, and UART pins. And then it basically interfaces with these pins and allows them to be interacted with and sent via a serial connection, whether it's the ADK or Bluetooth to your Android device. So it's a pretty cool project that I thought, but I like the Arduino platform better because of its standardized shields and whatnot that you can buy, and you don't have to really do a lot of soldering. It's a better modular system, so therefore I wanted to be able to do the same thing with Arduino. So my first board that I bought was the Arduino Mega 2560. I buy all my stuff on eBay here. So the 2560 is an Atmel, all like many other Arduino boards, uses an Atmel microcontroller, and has pulse width modulation, analog input, digital input and output, pulse width modulation, SPI and I2C, and UARTs. So I like the Mega because it has the most amount of pins, but it's essentially a regular Arduino board with USB host shield. So any Arduino board with a USB host shield could behave the same way. The Mega ADK board essentially has a USB Type A connector connected to a chip that operates as a USB serial port. And that's how you connect to your Android phone. The Mega ADK acts as a USB host, transferring information via serial to your device and also powering your Android device. So this board was pretty nice, however it is relatively expensive at $53. You could probably buy a Mega and a USB host shield for cheaper than they sell these boards. So the other board that I liked, especially because of its processor and the fact that it has a digital analog converter built into it also, is the Dewey. I think I'm pronouncing that right, I don't know. It has a 32-bit ARM Cortex processor with Atmel branding, and for around $20 you can have it shipped from China on eBay. This is the cheapest board you could possibly get, and with the most features and the most powerful processor. So it has everything that the other boards have, except this is the only one with a digital analog converter. It has two of them: GPIO, analog input, UART, SPI, and I2C. And it has two USB ports. One's connected to a smaller Atmel microcontroller, which does the in-circuit programming, and it's a serial port for programming debug messages. And then the other USB port is connected directly to the Atmel OTG pins, which can behave as mouse and keyboard and whatnot. So and it can behave as USB host or USB slave, I guess. and so that's nice. But it can also act as an ADK. So another thing I should note is, so this right here, I'm using Linux and Ubuntu. So the standard Arduino download for Ubuntu doesn't have this board in it at all. So basically, it has the Mega 2500, but it doesn't have to do it or any way to add it. So on Windows, once you have it, so you just do the standard download, go to Tools, Boards, Board, so there's the Mega, and then Boards Manager, and then right here where it says SAM, click on that and you would click Install, and then it would add support for the DUI. So then select the DUI, down here you see programming port, and then you'd be able to program it. So those are the boards. So another thing is Android phones. So why add a screen and whatnot when you can get an Android phone for less than like $60, $40, $40 to $100, and it has just about anything you could need to program it. So it has the screen and you can type stuff and create nice little widgets and all that. So, and then you can embed it into your project and not be out a lot of money. So I always liked this idea, and that's why I wanted to do this. So you can use an old Android phone, to interface with electronics, and so then you can save to an SD card and all this other stuff and whatnot. So or whatever, the sky's the limit on these. So another thing I wanted to add was Bluetooth support. The only thing that I really found was these modules, which are pretty nice. It's basically just a Bluetooth serial adapter, and then they operate at pretty high rates or baud rates. So I know they're greater than 115,200, but I'm not really sure what the UART capabilities of these Arduino boards are. But the only disadvantage is that on these, there's no way to know whether or not you're connected electrically. There's none of these pins interface into at least on the 6, the HC06, and there's the HC05. So the HC05 can act as a master or a slave, which means it can instead of just being able to request a connection, it can actually initiate a connection. But I got the 6, which it only has 4 pins connected, and these other 2 pins aren't connected, so there's no way for the device to know whether or not you're actually connected. So more on that later. So so you have one of these boards, you ordered it from eBay, and you want to connect it and get some programming going. So my idea as far as software sketches for Android, I wanted to be able to have my own firmware and be able to abstract the hardware to where I can say I want this certain pin to be an input or an output, or read an analog voltage, or transfer data to a UART or SPI or whatever, and then be able to interact with these boards. So I created a type of firmware, and then basically, so this is my firmware. I created a class that's basically a dynamic array. So I'm able to use memory in a way, create objects and stuff them into this dynamic array, and then basically then I can use that array to determine, what pins are assigned as inputs or outputs, and what data to send. And I created a protocol. So my protocol is just basically a bunch of definitions of integer values with some commands, so I can read the board model, the website, the firmware. I wanted to be able to interact with actual ports, which you can't do using Arduino. So that's write byte is kind of the start of that. So I have a pin setup command, and then all the different types of pins. So be able to set the prescaler. This was only, I did the research on this to make sure to get it to work on the Mega, but not on the Dewey yet. So basically you can define the frequency at which your pulse width modulation pins are running, rather than it being the standard 1000 hertz or whatever. So after you can set or clear a digital pin, you can set the duty cycle of a PWM pin, and then you can write to a digital analog converter. So then you can also, I wanted to be able to have the firmware do interrupts on certain pins. So if a pin, you can assign it as an input, but then you can say that I want to be able to generate an interrupt, whether it's high or low or whatever. So when it reaches a certain state, whether high or low, it will issue one of these commands and send it via the serial port, saying that the register has changed, and then be able to read analog pins, whether it's 8-bit, 10-bit. The Dewey is actually 12-bit, but it fits within this 2-byte guideline. And then read digital input. So after a pin is set up, these Arduino write commands, they get sent. So the basic structure of the commands is the command number first, and then the number of bytes, the data bytes that follow. So in this case, it's read digital input command. Number of bytes that follow is 2. First of which is the pin number, and the second of which is the data. So that's basically my protocol. Same for all of these. So then this one will be read board model, and then followed by 0 other bytes. So then that command gets sent, and then it will read the board model, and then send out the same command followed by a string. So right here, so I have my setup. So this is the basic code. I have my dynamic array to be able to store the pins that are set up as analog input or your regular input, digital input, or an interrupt. And then I have a pin process, so I can reset all the pins. And then this command right here is process all pins. So this will read the dynamic array, and then depending on the type of pin, will issue a command to be sent via the serial port. So and then it'll issue the proper command on the Arduino side. Digital input will be digital read, analog input is analog read, and then it actually stuffs it. Actually, I gotta change this. So you can see it's saying that, byte O of the buffer is the command, followed by 2 bytes, one of which is the pin, and then it maps the value, because it's either a 10-bit or a 12-bit value, into an 8-bit byte, and then it's sent out via the serial port. So then serial 1 write, which I have my Bluetooth thing connected to, sends it out, and then that's how it is. So I have analog input, analog or digital input, or analog. So once you set the pins up, it will the program will call this process pins, and then it'll do a read. So first it'll check to see if the value changed, and then it will perform a read and then send out the instruction. So then you'll get a constant stream of data about certain pins that you set up. And then this is my string sending function. So it actually uses malloc, and then does the command, and then the second byte is the number of bytes that follow, so it's a string length, and then it writes the entire buffer, which all this data gets copied into, to the serial port, flushes it, frees the memory, and then I have my pin setup function. So this is kind of the first thing that you do once you're connected to your Android device. You initiate pin setup. So basically, you add it to the dynamic array, and then you switch the mode. Depending on the type of pin, so it's any one of these, it will appropriately call the right commands to set the pin up as input or output, and then active high or low, the initial state for digital output, whether it's a digital input with the pull up enabled or not, and then if it's an analog input, it just sets it as input. And then PWM, it doesn't matter, because Android will, once you assign it a PWM, once you go analog write, it automatically switches it to output. So then if it's an interrupt type, it does this attach interrupt, and then so then these ISR functions basically just modify a byte. So this is my ISR register, which is a byte, and then it says bit set 0 through 5, whatever. There's actually 5 interrupts, so depending on which one it was, it will set the bit, and then it gets read. Also have the Bluetooth for the HC06. So then print response. Okay. So these are basically AT commands to get it to do set up the baud rate, the version, how you want it to show up. Like initially, it shows up as like HC06 or something. I got it to say something else, like Android or Arduino ADK or something. And then this sets the baud rate, which I set it to 115,200. So on my setup function, what I do is I do my serial begin to initiate messages on this serial port, and then serial 1 is my Bluetooth device. So then and then this is just a little test pin that I wrote. So then so I have my process instruction. So once an instruction is actually read on the serial port, it'll run this function, which then switches out the whole buffer has the instruction, the number of bytes, and then it has length. I'm not sure, I forgot why it has that. Oh yeah, the length of the buffer. So if the length is 3, it's one of these commands. If the length is 4, it's one of these commands. Because the DOI doesn't support set prescaler, I just commented this out. So I can build it, and then it'll work on either one until I get that working. So then case write DAC is the same thing. I commented that out because it only works on the DOI. So I got to add some L if statements. And then if the length is 2, it's one of these read board, model, website, or firmware. So then I just send a string out. So here's the actual loop after it gets set up. So while there's data available, I read it one byte at a time, and then do all this other, print it out, and then then I check to see if there's an instruction. It's kind of, I tried to do it the other way, but I kept losing bytes when I did the buffer type read, so I did it this way. And then I haven't lost any data since. And then after it processes the instructions on the serial port, or there's no more data available, it'll process the pins. And then, so that's pretty much it. So another thing that I just did was I made a Node.js thing for testing rather than do it all on Android. I wanted to be able to interface to the PC as well, because I don't know, I like JavaScript. The Yo-Yo uses Java for their PC implementation, and then it has like the kind of the same code base or whatever, which is nice. But I was really more concerned about getting the same firmware to work with either one, and using I didn't like the GUI custom GUI widgets on Java, so I'd rather do them in HTML. So I chose to use JavaScript and then Node.js. So that's what I did. So I'll talk about that for a little bit. So I have all these sketches in the code, the mega test, the DOI test, and then this Bluetooth test, which is actually kind of like the PC test. And then I have Arduino libs. So it's just the ADK2 was downloaded from the main website. The ADK min, I modified it, and I took out a lot of the code that was shipped with the ADK2. I guess I could do another video on that, but I don't feel like it. And then these two are kind of standard mega ADK codes for the actual USB host code to work with Arduino firmware. But then I have my node server, basically interfaces to the serial port, and the serial port's connected to the Bluetooth up here. So I right click and connect it. Then I can just do code here. Actually pretty simple, so it uses socket IO, and then that sends information to and from this web page. So I can run these commands here, and then it works pretty good so far. I have kind of this buffer overrun issue that I got to work out, but overall it's working. So a lot of the stuff that I'm doing here is working. So that's a good starting point. As far as the Java side of things, I have a lot of that code also working. I got a lot of shit open. Yeah, this is my ADK code for Android, so it's just an old Eclipse project. I know I'm supposed to switch to Studio, Android Studio, but I still haven't. So the source code, so I have my protocol thing and set up. And then I'm adding different boards, so I can issue a board command, and then it'll be able to do different types of to boards. So different boards have different pin capabilities and pin assignments, you know, as far as which pin number does what. So I don't want to issue a command for one and then it doesn't do that. So it's just basically like the static command and then a function to fill a buffer in the proper manner with these commands, so that I can send it. So I populate these buffers by calling the appropriate command. It returns that. So then there's that part. So I have this log command, and then this basically just interacts with a node server. So instead of actually logging to the console, which it works pretty crappily on here on this version of Eclipse anyway. So I just have it all go into another node server, and then I can see my messages there. So it's just a wrapper for the log. It's kind of boring. So the way I thought about coding it was to use these helpers. So I have an accessory helper and then the Bluetooth helper. The accessory helper does all of the USB type stuff. So I tested this on the Android and on the Dewey, and it works on both. So yeah, so it actually has to create like a thread, and then it runs. I don't know, I'm not really explaining this right. So it has all this freaking code, broadcast receivers and USB accessory, USB manager, and all this other stuff. So it basically just connects and then opens a stream, and then after it opens a stream, you know, it might need permission before it does that, you know. So if the device is detected, then it will ask for permission if it doesn't have it already. And then once it has permission, it will connect, and then it'll create a stream. After it creates these streams, it'll run a thread, and then inside that thread, you can send and receive to the stream within that thread. I suppose you don't have to create the thread, but it's probably not a good idea to have it running on the UI thread, because then your UI would be backed up by serial, waiting on serial, this and that. I'm not sure if either stream really blocks, but so basically this thread, this is just a test thread, so it have to read to clear the buffer or else get slow writes. Yeah. So I had this working, and then I have my Bluetooth helper, which is basically just the Bluetooth code. So this also creates a thread after creating the streams. So it'll connect to the Bluetooth, and then it will so I have two test threads. One's an echo, so it'll just print out whatever comes in. And then I have the code to set up the Bluetooth. This I actually got from the yo-yo code. If I change it for some reason, it doesn't work. This UUID. So then I have my activities. So my custom views, I have a graph that I programmed, a graph view, a knob switch, LED, so you can have little LEDs, an image button, which is exactly as it sounds like. I think my graph actually shows up. So I have this custom graph, but it shows up in the preview here, which is pretty cool. You don't have to run an emulator or show you on a device. So that's the test graph. So you can actually, graph the data on your Android device, and this thing automatically kind of scales based on the data. I need to add touch support so that it scrolls, or maybe I just add a scroll bar at the bottom or something. And then so the app will actually show up with the main activity, which is just a list of all the other activities involved. So I have this was FM Parallax was I was gonna interface to one of these I2C FM stereo devices. So, but there's basically the console activity, the graph activity, and the main activity. So then as you add other activities, you can add them to the list. And really, the way I should do things is the main activity doesn't have. It just extends Bluetooth helper activity. So then, it's just it's where I can test it, I guess. But it should run as a service, and both of these should be combined together to where it can be either Bluetooth or USB. So that's the ultimate goal there. But then I have I want to do these UI things, and then I'm working with the PC version. I got a lot to do, a lot of different places. But basically, let's see here. So that's where I am with that. And console activity, which is just it's just a console, and it doesn't even scroll good. I gotta figure out what's up with that. But it's just meant to print stuff out to the screen. So that's the Android code that I got going so far. And that pretty much concludes this this video. So if you have any questions, just put them down below, and I'd like to see what I got. Be interesting to see if anyone even watches this video. Thanks for watching. Later.